Bismillahirrahmanirrahim. Good evening. Today at this video, I will try to illustrate how I could to prepare the necessary parameters to can produce, to can uh, finish this doped perovskite oxide, lanthanum dot 67, calcium dot 33, manganese oxygen, or 3 atoms of oxygen to can be the perovskite oxide. Okay, what is the necessary parameters? I must prepare it to start at hydrolysis at soil gel. Hydrolysis, like I explained before, it was the first step in soil gel. What is the necessary? I must put in the glass. I must put the two solvents, pure water, hydrochloric acid, like my study. Uh, all of these are not organic. One of them, pure water, like I said before. The another is hydrochloric acid. After that, precursors, and I will explain why I must calculate them. Last thing, and the most important thing, is the agents, and I explained why we use it. That's related with the cracks, related with the cracks happen when wet gel convert to the dry gel by using simple evaporation process. Let's go to the next slide. The question is how I can prepare a nanoparticle from 3 gram from this structure, perovskite oxide, doped perovskite oxide, and how I can increase the nanoparticle size. That's related with the agents. That means agents have more than one benefit in soil gel. Let me start from hydrolysis. My video today about hydrolysis. How much I must put for precursors, how much I put it, I put from solvents, and after that, the last important thing was the agents. Here at first, let's calculate all the molecular weights to all this doped perovskite oxide structure: lanthanum 0.67, calcium 0.33, 1 mole of manganese, 3 atoms of oxygen. The molecular weight, how I can calculate it? I can calculate it by using the same mole number multiple the atomic mass of the metallic element. We can find it from periodic table. Now let's say this the atomic mass. The equation by that will be the molar ratio multiple the atomic mass to each one, and calculate all of them to be the molecular weight is 209.23 gram divided on. That's the molecular weight to this doped perovskite oxide. After that, from this angle, from this triangle, mass at up, from left molecular weight, from right molecular weight, from left mole number. I have 3 gram. I calculated the molecular weight. By that, I can calculate the molar number of all of these doped perovskite oxide. That's mean mass divided on molecular weight to can get 0.01433 mole. The mole number to all the structure is 0.01433 mole. Now, the mole number to all this structure. But how much I need? Mole number I need from all the metallic elements. When I say metallic element, that means lanthanum, calcium, manganese, except oxygen, because oxygen is not a metallic element. By that, I independently sure I will use another track to solve this problem. Now let's calculate the mole number to each one, I mean, I'm talking about the metallic elements, lanthanum, calcium, manganese. Now, to calculate how much mole I need of lanthanum, I will use equation number 5. It's important. To lanthanum, I will use the molar number, the molar ratio, the mole number. It's more appropriate. Dot 67 multiple equation 5. I need dot 0096 mole of lanthanum. Now let's talk about calcium. The mole number was dot 33 multiple equation 5. Equation 5 was the mole number to all this structure. We found it by calculate the mass divided on molecular weight. Now let's talk about the mole number of calcium equal dot 0.00472 mole. Now the last metallic element is manganite. We have 1 mole, multiple equation 5 to be dot 1433 mole. Now let's calculate all of these independent mole number to the metallic elements. To be equation 6, 7, 8, the total mole number to the metallic elements equal dot 0.2865 mole. This is very important. I will use it many times in next slides. Now, we prepared equation number 9. This equation acts the total mole number to just the metallic element and the perovskite oxide. Now, let's focus about how we can increase the nanoparticle size. First advantage to the agents, hydrocertic acid and ethylene glycol, to prevent the cracks when the wet gel convert to dry gel by using a traditional evaporation process. The second thing is we can increase the nanoparticle by increase the ratio of all of these agents, ethylene glycol, and certic acid. Now to increase the nanoparticle size by increasing them concentration, I will use X, that's mean the multiple ratio number, equal 1, 5, 10. That's mean I will use these numbers like multiple 5, multiple 10, and multiple 1 to can do comparison between them. Which nanoparticle is bigger at 1, multiple 5, or multiple 10? Sure, at multiple 10. By that, my structure will be, instead of writing 1, 5, 10, this is more appropriate. Lanthanum, calcium, manganese, O3, -1, -5, -10. Now let's talk about, first agent, certic acid. Let me start from certic acid. When X equal 1, I mean LCMO3/1 -1. The total particle size at equation 9, like I said before, it's very important. 1 multiple the total mole number to the metallic element in my structure equal dot 0.2865 mole because it's multiple 1. Now let's say I can calculate by using this scalar mole number, but I can scale grams. By that, let's convert this mole number to gram, to mass. How I can do that? By going to the Merck company to find the molecular number, molecular mass to the acetic acid, we will find it equal to 110.14 gram divided per mole. By that, that's mean mass will equal mole number at equation 9 multiple molecular mass from Merck company to be I need 6.0268 gram from acetic acid at multiple 1. Let's take a look at multiple 5. How much will we have two ways to solve this equation. We can directly say this number at equation 11 multiple 5 will equal 30.13470 gram, or we can use the long way to solve it. The particle size equal equation 9 multiple 5 to equal the total particle size number here. I won't calculate the mass. Molecular from Merck, we know it. By that, mole number, multiple molecular mass will equal 30.13470 gram. The same way with multiple 10. By using equation 9, multiple 10, and equation 14, multiple molecular mass to the acetic acid, you can say we have 16.2681 gram I need of acetic acid. I must calculate this number and put it in independent glass with appropriate solvent, with appropriate precursors. I will talk about the precursors and how I can calculate it at the next slides. Now, acetic acid agent is done. Let's talk about ethyl angelical from Merck company equal molecular mass equal 62.07. The molecular volume equal, I need molecular volume here. It's some important difference between acetic acid and ethyl angelical, because ethyl angelical is liquid, acetic acid is powder, like the other precursors. Let's come back. The molecular volume equal molar mass divided on density. Molar mass, I have it from Merck company. Density to the ethyl angelical equal 1.1132 gram divided on centimeter square to 43, sorry. By that, the molecular volume to ethyl angelical equal 55.7563 centimeter to 43 divided on 50. Now, what about when x equal 1, multiple 1? We can say, let's use equation 9, the total metallic number to all of the metallic elements, multiple 1, or we can use equation 10 directly from acetic acid. That's up to you. By that, 55.7563 multiple 0.02865 equal, I need 1.6 centimeter to 43, or we can say milliliter, 1.6 milliliter of ethyl angelical, because like I said before, it's liquid, not powder. That's mean I need milliliter, not grams. Let's talk about 5, the same thing. We can use equation 9, multiple 5, or we can directly use equation 12 from acetic acid and multiple with the molecular volume, sorry, to have, we need 8 milliliter. Here we noted when I increase the molar ratio, how much I need from all of these agents will increase too. At 10, we can say the same equation by using the long way, molecular volume 55 something, multiple total mole number of metallic element from at equation 14 from acetic acid, or you can say equation 9 multiple 10 and use it. I need 16 centimeter to force it, or let me say 16 milliliter. At 1, I was need 1.6 milliliter. We can solve at molar ratio, 10 molar ratio faster by say 1.6 at equation 17 multiple 10 times to be 16 milliliter, or you can use this way. I prefer this way. Now I have another problem. How I can calculate the mole number from all the lanthanum, calcium, manganites independently. I'm talking about the metallic elements at equation 6, 7, 8. And I need grams. How I can do it? Here we will use the precursor. I can find, like it's written there, I can find all of them independently because that I will use another structure, soluble in water, soluble powder in water. These are precursors to find them. Now let's talk about equation 6. The mole number I need of lanthanum dot 00696. By that, I will solve lanthanide nitrate hexahydrate in water. I will use lanthanide nitrate hexahydrate to come find the specific amount of lanthanum with 0.0069 mole. But how much I need from this powder? Let's calculate it. By using the same triangle, lanthanum nitrate hexahydrate, the mass equal mole number of this equation of equation 6 multiple the molecular of the lanthanum nitrate hexahydrate from Merck company equal 433.01. By that equation number 6 multiple the molecular mass I need 4.1568 gram of lanthanum nitrate hexahydrate. Now let's talk about calcium nitrate tetrahydrate. I need 0.00472 mole of calcium. By that, I will use calcium nitrate tetrahydrate in water, but how much I need? Let's calculate by using the same triangle. Mass up at right, molecular at left, mole number. That's mean mass gram equal mole number multiple molecular weight. Mole number is at equation 7.00472 multiple molecular of this structure from their company to can have 1.11 462 gram I need put in the glass with solvents from pure water and hydrochloric acid. The last one to how I can get 0.01433 mole of manganites. I will this equation mole number multiple the molecular mass of this structure, manganese nitrate tetrahydrate. Here it's 406, be careful. By that, mass equal 3.5969 gram of manganese nitrate tetrahydrate. You can reach 0.01433 mole of manganites. Now I will solve all of these agents, acetic acid, ethylene glycol, and the precursors, lanthanum manganese hexahydrate, manganese nitrate tetrahydrate, calcium manganate tetrahydrate with solvent 50 ml of pure water, 25 of hydrochloric acid inside this glass, and use this glass pen to stir this liquid and try to do not homogeneous, but to be sure all of these precursors will solve with solvents and with agents. That's it. This video today is finished. Thank you for watching, for listening. Have a good day. Let me say that again. When I started to recording video by using my channel, I say we study together. I'm not teacher. I'm not learning anyone, but I'm sharing my experience, my steps, my results with another research. That's it. Thank you about your listening or watching again. Have a good day. See you in the next video.